Imagine a celestial ballet of light and magnetism, a dance of colors swirling across the polar night sky. This isn't a scene from a science fiction novel, but a natural spectacle known as the Aurora Borealis, or Northern Lights. These stunning displays are not just a feast for the eyes, but also a complex phenomenon resulting from geomagnetic storms, cosmic disturbances that can affect everything from satellite operations to power grids on Earth. Understanding these phenomena is not just an academic endeavor, it's crucial for our technological society. This essay will explore the intricate dance between Earth and the Sun that gives rise to geomagnetic storms and the Aurora Borealis. We will delve into the causes of these storms, their effects on our technological infrastructure, and the breathtaking beauty of the auroras they create. By understanding these powerful natural events, we can better prepare for their impacts and appreciate their majesty. Geomagnetic storms begin with the Sun, our star, which continuously emits a stream of charged particles known as the solar wind. This solar wind carries with it the Sun's magnetic field, extending out into space in what is known as the heliosphere. When this stream of particles meets the Earth's magnetic field, it can create disruptions. These disruptions are the first step in the chain of events that lead to geomagnetic storms. The intensity of these storms depends on the strength and configuration of the solar wind and the existing geomagnetic conditions. The most significant triggers of geomagnetic storms are coronal mass ejections, CMEs, large expulsions of plasma and magnetic fields from the Sun's corona. When these CMEs, laden with enormous amounts of energy, collide with the Earth's magnetic field, they can cause substantial disturbances, leading to the phenomena we observe as geomagnetic storms. Sunspots and solar flares. Catalysts of celestial disturbances. Sunspots are darker, cooler areas on the surface of the Sun, where intense magnetic activity inhibits convection and results in reduced surface temperature. These areas are often precursors to solar flares, sudden eruptions of energy and light. Solar flares significantly influence Earth's space weather, especially when they occur in conjunction with coronal mass ejections. These powerful bursts of solar wind and magnetic fields can arrive at Earth within days, initiating geomagnetic storms of varying intensities. Understanding the solar cycle, the periodic change in the Sun's activity and appearance, including variations in the number of sunspots, is crucial for predicting when geomagnetic storms might occur. This knowledge helps scientists and technologists prepare for potential disruptions. Impacts of geomagnetic storms on modern technology. The repercussions of geomagnetic storms are far-reaching, affecting various sectors of modern technology. One of the most critical impacts is on power grids, where induced electrical currents can cause blackouts and damage transformers, disrupting electricity supply. Satellites in orbit can also suffer from these storms, experiencing malfunctions due to increased radiation or being knocked out of their intended orbits. Communication systems, including radio and GPS, are susceptible to disturbances from space weather, leading to decreased accuracy and reliability. Historical instances, such as the Quebec blackout of 1989, serve as stark reminders of the potential severity of these storms. Such events underscore the need for robust infrastructure and prepared strategies to mitigate the effects of future geomagnetic disturbances. Watching the skies, tracking and predicting geomagnetic activity. Organizations like NOAA's Space Weather Prediction Center play a crucial role in monitoring geomagnetic activity. Using a combination of ground-based observatories and spaceborne satellites, they track solar wind conditions, sunspot activity, and other relevant parameters to forecast space weather. The ability to predict geomagnetic storms allows for timely warnings to industries and governments, enabling them to take protective measures. Advanced technologies, including AI and machine learning, are increasingly being utilized to improve the accuracy of these predictions, helping to safeguard our technological landscape. The science of the Aurora Borealis is truly fascinating. It's a direct result of geomagnetic storms, When charged particles from the solar wind penetrate the Earth's magnetosphere, they are funneled towards the poles by magnetic forces. Here, they collide with molecules of atmospheric gases like nitrogen and oxygen. These collisions excite the atoms, causing them to emit light as they return to their ground state. The colors of the aurora, predominantly greens and reds, are determined by the type of gas involved and the altitude at which the collisions occur. Auroras are primarily seen in green, but they can also appear in red, blue, and violet, depending on the gases involved and their altitude. Oxygen, at around 60 miles up, emits a brilliant green, the most common color of the aurora. At higher altitudes, it can also produce a rare red aurora. The interaction between solar particles and different atmospheric gases creates this spectacular variety of colors. Factors such as the intensity of the geomagnetic storm and the concentration of gases at different altitudes also influence the appearance of the aurora. For those eager to witness the magic of the Aurora Borealis, there are several tips to enhance the experience. Areas with dark skies away from city lights offer the best visibility. Timing is also crucial. Auroras are typically more active around the equinoxes due to the alignment of the Earth's axis and the Sun. Patience is essential, as aurora activity can be unpredictable. Utilizing aurora forecast services can significantly improve the chances of a successful viewing, providing real-time updates and predictions on aurora activity. Geomagnetic storms, a risk management perspective. Various sectors implement strategies to mitigate the impacts of geomagnetic storms. Power companies, for example, may install devices to protect the grid from geomagnetically induced currents. Satellite operators use specialized forecasting to manage the risks to their spacecraft during heightened solar activity. Preparedness and resilience planning are essential, especially as our reliance on technology grows. Understanding the potential risks and implementing effective mitigation strategies can significantly reduce the impact of these solar disturbances. Geomagnetic storms do not respect national boundaries. Their effects can be felt worldwide. Different geographical regions may experience varying impacts based on their latitude, infrastructure, and preparedness levels. For instance, countries at higher latitudes are more likely to experience the effects of auroras, but also face greater risks from geomagnetically induced currents. Developing a global perspective on geomagnetic storms is crucial for international cooperation and coordinated response strategies. Continued advancements in space weather research promise to enhance our understanding and forecasting of geomagnetic storms. Emerging technologies such as more sophisticated satellites and more accurate models are being developed. These advancements will not only improve our predictive capabilities, but also our ability to protect our technological infrastructure. The ongoing research is crucial for developing more effective mitigation strategies and for deepening our understanding of Earth's complex relationship with the Sun. Beyond their scientific interest, auroras hold a special place in many cultures around the world. They inspire folklore, influence art, and attract tourists seeking their breathtaking beauty. The Aurora Borealis reminds us of our planet's connection to the broader solar system and the dynamic processes that drive our universe. These lights are a spectacular reminder of the beauty and complexity of the natural world. As we unravel the mysteries of geomagnetic storms and the Aurora Borealis, we gain not only knowledge but also a profound appreciation for the dynamic and beautiful interplay between our planet and the Sun. These phenomena, while potentially disruptive, also highlight the resilience and adaptability of human society. By embracing both the dangers and the wonders of these celestial events, we can approach the future with a better understanding and a greater capacity to respond to the challenges and opportunities presented by our dancing skies. Now that we've journeyed through the mesmerizing world of geomagnetic storms and the Aurora Borealis, it's time to keep the conversation going. If you're fascinated by the wonders of our universe and eager to learn more, make sure to like this video, subscribe to our channel, and hit the notification bell. Follow us on social media to stay updated with our latest videos, and join a community of curious minds. Don't forget to share this video with friends and family who share your passion for the mysteries of the cosmos. Your engagement helps us bring more content like this to you. Let's continue to explore the incredible dance of our universe together.